There is a big push to reduce carbon in construction. So where is it in our buildings? There are two different areas. The first is the embodied carbon in the construction materials we use. For example, the greenhouse gas emissions produced as a building material is manufactured. The second source is the emissions that are produced when the building is occupied, from things like electricity for heating, running the fridge, or hot water. Carbon emissions from materials occur right across the building's life cycle. It's not just manufacturing that might emit greenhouse gases, but construction, maintenance, things like repainting the outside walls, and end-of-life stages too. So when considering the carbon in a material, we need to understand its whole life cycle. Consider a new build house in Auckland. It's a single-storey, 4-bedroom house just under 200 square metres. It sits on a concrete slab, has timber framing, clay brick wall cladding, double-glazed aluminium windows, and a metal roof. Inside, it's carpeted. Let's look at some of the main materials used over the different processes. First, manufacturing. The concrete floor slab and sheet metal roofing make up a large part of this house's carbon emissions in their manufacture. Traditional ways of making steel and concrete release a lot of carbon dioxide into the atmosphere. It's worth noting here that concrete with supplementary cementitious materials can help to reduce the carbon footprint of concrete. Sustainably grown timber with FSC or PEFC certification goes the other way into a negative measure of emissions. Trees actually capture carbon dioxide from the atmosphere as they are growing and store it. During construction, the concrete slab, timber framing, and brick cladding have the most noticeable emissions for the house. From transport of materials to site, manufacture of materials that are wasted, and so on. Thirdly, maintenance. This includes replacing materials during the building's 90-year service life, which may occur multiple times. At each replacement, the material is manufactured, transported and installed, and the old material is recycled or disposed. As you can see, taking maintenance into account can have a major impact. Pile carpets are likely to be replaced several times over the life of a building. New carpets need to be manufactured, transported to site and installed, and old carpets disposed of. The carbon footprint has grown because of this. The profiled metal sheet roofing is also likely to need recoating or replacement over the life of a house. The carbon footprint of waterborne paint suddenly becomes visible at this point, as repainting is carried out many times over the years. At the end of life of a building, more emissions arise from demolition or deconstruction, transport, and disposal of materials. Here, natural materials such as timber can begin to biodegrade in landfill, if not reused or recycled. Some wastes may be processed to help turn them back into useful materials again. Finally, let's consider potential benefits achieved from recycling or reusing a material at the end of its life. Materials made from metal make some gains here, as they may be recycled or reused in different forms. So how does it all balance out in the end for each material? Carpets, sheet metal roofing, and the concrete floor slab are the highest lifetime contributors of CO2 in this particular house. Timber, assuming it is from a sustainably managed forest, is the lowest, with a negative contribution. What about the second source of carbon in our buildings, from their operation? BRANZ modelled the carbon emissions of 10 houses over a 90-year service life. These included space heating and cooling, water heating, lighting, and plug-in appliances. When measured over a shorter space of time, to 2050, when New Zealand has set its net carbon zero target, the contribution from materials is larger than the operation. But over a 90-year service life, the operational energy becomes larger. The biggest demands on energy are plug-in appliances and water heating. This may change over time too though, as the national grid becomes less reliant on non-renewable energy sources. So what have we learned? Some materials, such as concrete and steel, have high emissions just from manufacture. Timber from sustainable forestry stores CO2 from the atmosphere while the product is used in the building. Maintenance and replacement of materials such as carpets can have a huge impact on their lifetime carbon footprint. Some materials, such as steel, can make gains at end of life because they can be recycled. The only way to fairly assess the carbon footprint of a material is over the whole life cycle of a building.